Our first topic in Mod 2 is special triangles. We have two types of special triangles, the 45-45-90 triangle and the 30-60-90 triangle. You have probably seen both of these in the past, most likely in a geometry class, but it's also probably been a while since you've had to deal with them, and you may well have forgotten these relationships. In a 45-45-90 triangle, what you need to remember is that the legs have the same length. The legs of a right triangle are always the two sides that create the 90-degree angle. In a 45-45-90 triangle, the hypotenuse is always the length of the leg times the square root of 2. In a 30-60-90 right triangle, your shortest leg is always the leg that's across from the 30-degree angle. And if you think about it, that makes sense because that's the smaller angle, so the side across from it is going to be shorter. The length of the leg across from the 60-degree angle is the length of the short leg times the square root of 3. The length of the hypotenuse in a 30-60-90 is the length of the short leg times 2. In example 1, we are asked to find the missing sides in the triangle, and we are also told to leave the answer in exact form. On these problems, you will be given a picture, and one of the sides will be labeled with a variable. That is the side that you are being asked to find. When we look at this first figure, we are given a 30-60-90 right triangle. The side that we are given is the long leg. The side that we are looking for is the short leg. So we want to use the relationships of a 30-60-90 triangle. You must have these relationships memorized. What we know from our given rule for 30-60-90 triangles is that the long leg is always the short leg times the square root of 3. So we know that 5, which is our long leg, is the length of our short leg, which is b, times the square root of 3. We want to know what b equals. So we are going to divide both sides by the square root of 3. And we get b equals 5 over the square root of 3. You may leave your answer in that form. That is absolutely fine. Or you can rationalize it and rewrite it as 5 square root of 3 over 3. This is the exact form that the directions tell us to leave the answer in. Do not put square root of 3 into your calculator and get some kind of a decimal value. When they say exact form, they want you to leave any square roots that are in your answer in that answer. On our second figure, we are given a 45-45-90 right triangle, and we are given that one of the legs equals 2. Remember that in a 45-45-90 right triangle, the legs are always the same length. So we know that automatically the other leg is also 2. Even though that's not what we were being asked for, we do know that. The letter we are looking for is the hypotenuse, which is h. Our relationships for 45-45-90s tell us that the hypotenuse is the short leg times the square root of 2. So our hypotenuse, or h, equals the length of our short leg, which is 2, times the square root of 2. And in this problem, we are now done. That is our answer, and it's in exact form, so we are not going to do anything else to it. For our third figure, we are given another 45-45-90 right triangle. And this time we are given that our hypotenuse is 5 and that our leg is a, and we are asked to find the variable a. Now remember, we know that the hypotenuse is always the short leg times the square root of 2. Our hypotenuse is 5. That must equal the short leg times the square root of 2. We need to know what a equals, so we are going to divide by the square root of 2 on both sides. And we now have that a equals 5 over the square root of 2, which is a perfectly acceptable answer, or you can rationalize it and write it as 5 square root of 2 over 2. On the last figure, for example 1, we are back to a 30, 60, 90 degree right triangle, and we are told that the shortest leg has a length of 3, and we are being asked to find the hypotenuse. Remember that the hypotenuse in a 30, 60, 90 is always short leg times 2. So we know that D, our hypotenuse, has to equal the short leg times 2. So we know that D equals 6, and we are done.